Alright, this is Volumes of Known Cross-Section by Matt and Maddie. So we're going to do a sample problem for you.
Okay, I'll read the problem. It says the function is y equals x squared and y equals 2, and the y-axis makes up the base of a solid of the known cross-section. Each cross-section is a square. Find the volume such that the square is A, parallel to the x-axis, and B, parallel to the y-axis.
Alright, so we're going to do number A and graph it. Alright, so what we're going to do is it's going to be parallel to the x-axis, so draw a line from the y-axis parallel to the x-axis. And then we know that it's a square, so each side is the same. So you go up as well, and all of those sides are the same length.
Side and side. Okay, and so the s is equal to the x value, and y is equal to x squared. So you're going to want to find this in terms of x. And so x is equal to the square root of y, because y is equal to x squared. And so that'll help you find it.
So the area of each of the boxes is s squared. So if we want to find the volume of the entire shape, we need to take the sum of all the areas. And to take the sum, we're going to use an integral. The integral from a to b of s squared. And because we got this in terms of y, it's going to be dy instead of dx. Alright, so a is the first limit of integration, and it's going to be the bottom end of the shape, right there. And then b is the second limit of integration, and it's going to be the other end of the shape, the top end. So that whole top part.
This line.
Yeah. So we know that a is at 0, because that's right at the bottom. And then b is at 2.
Yep.
Alright, so we're going to do the integral from 0 to 2 of the square root of y squared, which will just be y, and then dy. And that'll get you the answer.
Yeah. Okay, so when you plug this in to your calculator, you find that the volume is 2. And now you're done with part A.
Alright, so now we're going to do part B, which is going to be parallel to the y-axis. So she's drawn that.
It's not too great.
We'll call each side S again. But this time, it's not the distance between the x and the y-axis, the x value and the y-axis. Now it's the difference between the bigger y equals 2 and the y equals x squared.
Yeah, so the values of the function.
So because of that, we know that s equals 2 minus x squared. So that's going to be the distance for each value of s. Okay, so what we're going to do this time is, since we already know it's the integral of s squared, we're going to do the integral from a to b of 2 minus x squared, and then all of that's in parentheses, and that's all squared, dx.
dx. Sorry.
So a is going to be 0 again, but this time, because we're integrating and the boxes are going from left to right instead of from bottom to top, b is going to be where the graphs intersect. And you can set the graphs equal to each other, and you're going to find out that that is where y equals square root of 2. Or excuse me, where x equals square root of 2.
Yeah, so that's going to be your second limit of integration.
Mm-hmm.
Okay, so once you've found the limits of integration, you're just going to plug s squared in to the equation, and then when you solve that, you're going to find that your volume is 3.01699. Thanks.